right, so this is the last lesson we're going to do from section 5.1. So we'll call it 5.1D. Sorry. And this lesson is all about fractions. So there's two things we're going to do. We're going to add and subtract trig fractions, and we're going to take a trig expression that is a fraction, and we're going to write it so it's not. So the title we're just going to call adding fractions containing trig functions. I'll say trig expressions, that's better. Okay. So what is your number one rule for dealing with fractions if you want to add them? Right. So number one rule for adding fractions is you must have a common denominator. Now, we have been finding common denominators and adding and subtracting fractions all year. So this is not new. The new part of it is there's some trigonometry involved, and then after we add, then we'll use some identities to simplify. But overall, this is a lot of the same stuff we've already done. Okay. So for our first example, the directions are to add, then use the identities to simplify. All right, so our first fraction is sine of theta over 1 plus cosine of theta plus cosine of theta over sine of theta. All right, now I hope you guys see cosine of theta over sine of theta and think cotangent of theta, because you'll need to know that tomorrow, but we're not doing that on this problem. The directions on this problem are to add the fractions. And if we do that, it really won't help us get to the answer. So to add those, we need an LCD, least common denominator. So we need our denominator to have everything both of these denominators have, which is going to be a 1 plus cosine of theta for the first fraction.
You can see your reflection, that's okay. It's hard to see. See your mirror right here? Like move a little. Yeah, move a little bit. Wait, like your head. Yeah. Just like yourself.
Okay. All right, it's okay. And then what else needs to be in my LCD? The sine of theta. Okay, so I'm going to rewrite both of these with a longer fraction bar, and then we're going to make each of them have the LCD. So what does the first fraction need to have the LCD? A sine of theta. So what we'll do is multiply the denominator by the sine of theta, but to keep it legal mathematically, we also multiply the numerator by the sine of theta. All right, and then for our second fraction, we're going to need a 1 plus cosine theta. And then at this point, I like to just make one long fraction bar and go ahead and put the LCD as your denominator. And then on the numerator, we'll just multiply, add, do whatever we have to do to simplify the numerator. So we do need to multiply sine of theta times sine of theta. Right? This one's addition, so we just bring down the plus sign. If it's subtraction, you do need to make sure you distribute the negative, so be careful with that. But here, we just need to distribute cosine of theta. Okay, so now's where we want to look at the identities. So what do y'all think? Can we use an identity somewhere on this problem? Preferably the numerator. Yeah, we have sine squared plus cosine squared. That together is going to be 1, so he's right. It's going to be 1 plus cosine of theta in the numerator. And then the denominator, we'll just bring down our LCD that we found. All right, and then now what can we do? You can cancel, right? We don't have to use an identity. With numerator, it has 1 plus cosine theta, and the denominator has 1 plus cosine theta. So we can cancel those. Everything cancels out of the numerator. What's up there? A 1. And then what is 1 over sine of theta? Cosecant of theta. There it is. All right, now I want to talk about a couple of other things that might happen. So I think so far, every time we've used those reciprocal identities, there's been a 1 in the numerator, but it doesn't have to be a 1. So let's pretend like we did a bunch of work and we got down to 3 over cotangent of x. What do you guys think that equals? 3 tangent of x. So it doesn't have to be a 1 up there. There can be a different number up there. So for example, we could have -4 over sine squared of x. And that's just going to end up being -4 and then cosecant squared of x. So we've known we can use those reciprocal identities with squared terms and cubed terms and everything. Okay, one more I want to show you. This one's a little different. So this time my numerator is not a number. The numerator is the cosine squared of x. And then the denominator is secant squared of x. You think we can still use this identity, the reciprocal identity? We can. So just like on the last one, the -4 just stayed -4. What is in the numerator, cosine squared of x, is just going to stay cosine squared of x. All right, and then I'll use the reciprocal identity for the secant squared in the denominator. So what is that going to be in the numerator? If I use the reciprocal identity, it's going to be cosine squared. And then what's that going to be? If you multiply those, what do you get? Cosine to the fourth of x. Right, so as long as there is only a single term in the denominator, like a single secant squared, a single sine squared of x, a single cotangent of x, we can use the reciprocal identities. Now on one like this one, we could not use it because it has that +1. So we can't just move cosine of theta up and change it to secant. We cannot do that. That one. All right, any questions?
Where did you get why did you get cosine squared of x times cosine squared of x?
Okay, this cosine squared is
Well,
this
You
one.
got that from, where did the other one?
Because it's secant squared in the denominator, I can use the reciprocal identity. So that's cosine squared in the numerator. Just like this one was sine squared in the denominator, it's cosecant squared in the numerator. So same property. All right, any other questions? Okay, we have one more thing to do, and it's rewriting so we don't have a fraction. So this is example 2. Rewrite the expression so that it is not in fractional form. Okay, so this one we have cosine squared of x over 1 minus sine of x. I'm pretty sure we did this one the other day using identities and then factoring. But I want to show you another way to do it if you wanted to. Sometimes this helps. So basically what we want to do is get rid of our denominator somehow using properties. So to start this off, what we do is multiply by I'm going to call it conjugate in quotes, because most of the time when we talk about conjugates, we're talking about complex conjugates with imaginary numbers. So I'll remind you what that means. So we're going to multiply by the conjugate of the denominator. Okay, so conjugates. Back in, I don't know, it's been a while. We were talking about complex numbers. Let's say you had the number 2 minus 3i. What would its conjugate be? I didn't hear you. Anybody remember? It used those same numbers. 2 plus 3i. All right, so that's what we're going to be doing with these trig problems. They're not technically conjugates, but it's the same idea. All right, so what we'll do is we'll take this problem, and then we're going to multiply by 1 plus sine of x. Now again, to keep it legal, we have to also do that in the numerator. So we're kind of tricking the problem into one of your identities is what we end up doing. Now it is important that on the numerator, we're not multiplying it out, okay? We're just gonna leave it in factored form because we want something to cancel out our denominator. So we're just gonna leave it in factored form, which will make it easier to cancel. And then in the denominator, we do need to multiply, but because they're kind of like conjugates, we don't have to distribute everything twice. We can just do 1 times 1, and then negative sine of x times sine of x is negative sine squared of x. Okay, so look at your identities. Does 1 minus sine squared of x equal something? does cosine squared of x. So let's replace it with that. Right, and then this is exactly what we want to happen. The cosine squared of x's will cancel out, and we're just left with 1 plus sine of x, which is not a fraction. That's what we were looking for. Right, so that's just another skill you can use to simplify these. That one doesn't come up quite as much as a lot of the other stuff we've talked about. Okay, so study for your memorization quiz, and then I have a little worksheet for you.